Consider a harvester ant colony in the New Mexico desert. No single ant knows where the food is. No ant gives orders. Yet the colony converges through pheromone trails and local interactions. A Stanford dissertation completed in 2019 under Deborah Gordon asked how individual neurobiology gives rise to colony-level collective behavior. That is how a field observation becomes a research question. Every research project begins as a hunch. The first task is to discipline it. Write the idea in one sentence. Then ask, what would I need to measure? And, what outcome would prove me wrong? If you cannot answer both, the idea is not yet a question. A generative model describes how hidden causes produce observations. In research, the idea is the hidden cause. The measurement is the observation. The question is the likelihood function. The 2021 paper Active Inference in Frontiers in Behavioral Neuroscience operationalized this. It modeled ant colony foraging as distributed active inference, making specific predictions about pheromone dynamics that could be measured and tested. The finer criteria. Feasible with the resources you actually have. Interesting to you and to others. Novel, it adds to what is known. Ethical, it does no harm. Relevant to a community. A question failing any one criterion will struggle to survive the research process. The free energy principle gives this formal grounding. Free energy is an upper bound on surprise. A good research question minimizes expected free energy, it reduces uncertainty about the world, which is the epistemic value, while also being achievable with available resources, which is the pragmatic value. The Markov blanket is the boundary between what an agent can observe and what it cannot. External states are behind the blanket. Sensory states mediate what comes in. Active states mediate what goes out. Internal states are what the agent infers. In research, the question's Markov blanket is the boundary between what you can measure and what you must infer. Falsifiability is the acid test. A question is scientific only if some conceivable observation could prove it wrong. The 2018 paper of Woodlice and Men, co-authored with Carl Friston in the ALIUS Bulletin, made specific predictions about cognition across species that could be confirmed or disconfirmed by data. If nothing could disconfirm the claim, it would be philosophy, not science. Checkpoint. Can you state the research question using PICO? Population, what or who is studied? Intervention, what is being tested? Comparator, compared to what baseline? Outcome, what is measured as result? If all four are filled, the question is sharp enough. In active inference, the posterior is proportional to the likelihood times the prior. In research, the prior is the existing literature. A weak prior means a weak posterior, no matter how strong the evidence. The Bayesian model of research makes this explicit. The posterior probability of the contribution being correct is proportional to the likelihood of the evidence times the prior from existing work. The belief update diagram visualizes the process. The prior is the initial model. The likelihood is what the data says. The posterior is what you believe after combining them. Research is iterative belief updating, one paper at a time. A concrete example. The 2022 systematic literature analysis of the free energy principle on Zenodo surveyed the intellectual landscape of over 500 papers. Without that systematic review, new contributions risk reinventing existing work. The review is the prior that makes novelty claims credible. A common mistake, reading only agreeable papers. This is confirmation bias. When building Cerebrum, the case-enabled reasoning engine published on Zenodo in 2025, the design required comparing against existing cognitive architectures and acknowledging where alternatives were stronger. The ELBO decomposition makes the cost of ignorance precise. Free energy bounds surprise from above. The gap is the KL divergence between the posterior and the true belief. In research, this gap is the cost of not knowing the literature. You pay it in rejected papers and rediscoveries. Finding relevant literature is a skill that improves with practice. The tools available today are more powerful than what university libraries offered a decade ago, and they are all free. The Search Toolkit. AR14 for STEM preprints. Google Scholar for breadth. Semantic Scholar for AI-powered recommendations. PubMed for life sciences. Connected Papers for citation graph visualization. SciAR14 for psychology. BioArXiv for biology. And the Open Science Framework for work in progress with DOI assignment. The Snowball Technique. Find one highly relevant paper. Follow its references backward to the origin. Follow citing papers forward to the latest extensions. When Friston's 2010 free energy paper was found, snowballing it produced a network of hundreds of papers that became the foundation for the entire active inference research program. Boolean operators refine searches. And narrows. Or broadens. Not excludes. For example, active inference and ant colony not pesticide filters out agricultural papers when the interest is collective behavior. Checkpoint. A paper from 2019 already did what was planned. The right response is not abandonment. Cite it, build on it, and reframe the contribution as an extension. Feedback reduces the gap between the researcher's model and the community's model. Each round is a Bayesian update. Without feedback, the work optimizes against a potentially wrong prior. The feedback channels available to independents. Open review platforms give structured preprint feedback. The Active Inference Institute runs weekly live streams with over 500 recorded sessions where anyone can present work in progress. Research communities on Discord and Slack offer real-time discussion. Direct email to cited authors works more often than expected. And OSF supports sharing work with DOI assignable preprints. The free energy decomposition shows why feedback matters. Free energy is complexity minus accuracy. Without feedback, complexity grows unchecked and accuracy stagnates. Feedback attacks both. It forces simplification and exposes where the model is wrong. How to handle criticism. Do not defend. Write down every objection. Categorize, structural, factual, or stylistic. Address each one. If a criticism stings, investigate it. The 2023 Generalized Notation paper emerged partly from community feedback that the field needed a standard notation dictionary. Without an institutional affiliation, the prior on the work is lower. Credibility is the signal that raises it. It must be built deliberately, layer by layer. The credibility stack. Foundation, an ORCID, a persistent 16-digit identifier that distinguishes you from every other researcher. It is free and takes 2 minutes. Above that, preprints on AR14, OSF, or Zenodo. Then, open data and code on GitHub. Then, talks at community events. Then, peer-reviewed publications. Each layer makes the next one easier. Credibility as a free energy landscape. At the start, every contribution is high surprise. As preprints accumulate and code is shared, surprise decreases. Contributions descend toward the minimum: accepted, expected, trusted. Reproducibility is the strongest signal. When code, data, and the analysis pipeline are public, the work says, anyone can check. The 2020 paper on gene expression variation in harvester ant foragers, published in Communications Biology, shared data and analysis code alongside the paper. The 2018 paper on dopamine and collective foraging in iScience showed that dopamine regulates colony-level foraging decisions, a finding made credible by open methods. The 2026 template approach to reproducible generative research on Zenodo demonstrates the full pipeline, configuration through publication. The 2019 paper in Synthese asked whether ant colonies could be a test for scientific theories of consciousness. That paper was credible because it was specific. It named the theories it tested, the predictions it derived, and the observations that would confirm or disconfirm each. Specificity is credibility. Vagueness is the opposite. The expected free energy decomposition explains why open code matters. A paper without code has high epistemic uncertainty. Reviewers cannot verify claims. A paper with code reduces that uncertainty. The pragmatic value is that others can build on it immediately. Checkpoint. Which builds credibility fastest for an independent? When presenting a new theoretical framework, certain mistakes appear repeatedly. Naming them helps avoid them. Mistake 1: the grand unification claim. Saying a framework explains everything from consciousness to quantum mechanics. Reviewers distrust scope claims that are too broad. Narrow to what can be demonstrated. Mistake 2: no comparison to existing approaches. Compare to at least 2 alternatives. Show where yours is better. Show where yours is worse, honestly. Position, do not just advocate. The Cerebrum framework compared against existing cognitive architectures and acknowledged their strengths. Mistake 3: jargon without definition. Terms like precision, policy, and generative model mean different things in different communities. Define every technical term on first use. The 2023 Generalized Notation paper addressed this for the entire active inference field by providing a standard notation dictionary. Mistake 4: no worked example. A framework without a concrete example is a recipe without ingredients. The ELBO decomposition shows how a bar chart makes an abstract inequality tangible. Show one instance applied to a real problem, with numbers, tracing each step. A framework without an example is an unfinished thought. The example is what turns an idea into a contribution that a reviewer can evaluate. The format chosen shapes the feedback received. A conceptual paper introduces a framework. A review synthesizes existing work. A case study applies a framework to one instance. A pilot study is a small empirical test. A protocol describes a method. A commentary responds to published work. The 6 formats and when to use each. The platforms. Preprints, R14, bioRxiv, CR14, OSF, Zenodo. Peer review, journals, Open Review, PCI. Talks, Neuromatch, Active Inference Institute livestreams, Complexity Weekend. Code, GitHub, Zenodo, Hugging Face. The Active Inference Institute publishes through Zenodo with DOIs, making every output citable. Annual ecosystem snapshots in 2023, 2024, and 2025 document the community's growth. The perception action loop applies to communities. A community acts through outputs, papers, code, talks. It observes the response, citations, downloads, engagement. It updates its model. A healthy community keeps this loop tight. The Active Inference Institute is a 501c3 nonprofit with a scientific advisory board including Carl Friston, Thomas Parr, Chris Fields, and Michal Albarracin. It runs textbook groups through the Parr, Pizzulo, and Friston textbook, with 10 cohorts completed. The internship program, running since 2022, has trained researchers in active inference modeling. The Fellows program has 5 research fellows. The mentorship program launched in 2024. Complexity Weekend is an annual unconference co-founded in 2019. The AII internship program is worth highlighting. Since 2022, interns work on open-source active inference software, publish preprints, and present at the annual symposium. It is a structured path into independent research. You get a project, a mentor, a community, and a publication. For many interns, it is their first experience producing publishable research outside a university setting. Finding mentors and collaborators. Do not ask someone to be a mentor. Engage with their work substantively. The collaboration with Carl Friston began with a co-authored paper on cognition across species, not with a request for mentorship. The AII mentorship program formalizes this. It matches researchers based on shared intellectual interests, not on requests for guidance. Collaboration emerges from mutual intellectual respect. The 2023 paper Distributed Science, published on OSF, models the scientific process itself as multi-scale active inference. Individual researchers are agents minimizing local free energy. The scientific community is a collective minimizing global surprise. Peer review is belief sharing between agents. The POMDP of research. The A matrix is the likelihood, what is observed given the hidden state. The B matrix is the transition, how the field changes when you act. The C matrix is preferences, what outcomes are valued. The D matrix is the prior, what is believed before starting. Every research project has all four. Federated Inference and Belief Sharing, published in Neuroscience and Biobehavioral Reviews in 2024, describes how agents share beliefs without sharing raw data. In science, this is what peer review does. Researchers share posterior beliefs through papers, and the community updates its collective prior. The factor graph shows how messages propagate. Precision weighting explains attention in research. The prediction error between expectation and observation is weighted by precision. High precision means the data is trusted. Low precision means the prior is trusted. In cognitive security research through CogSec, this maps to how agents weight different information sources in narrative ecosystems. The predictive hierarchy of research. Level 1 is the data. Level 2 is the method. Level 3 is the theoretical framework. Predictions descend, errors ascend. The 2025 ThoughtSeeds paper in Entropy demonstrated this. It connected meditative cognition data to methodological choices to the theoretical framework of hierarchical active inference. Generative research teams, described in the 2023 Zenodo paper, are compositions of active inference agents that produce research collectively. The Active Inference Institute is a case study, a research team distributed across the globe, sharing beliefs through preprints, code, and live streams, minimizing collective free energy. CogSec, the Cognitive Security and Education Forum founded in 2018, applies the same model to information ecosystem research. Open science is not an ideology. It is a set of concrete practices that make research more credible, more reproducible, and more accessible. Practice 1: Pre-registration. Before collecting data, write down the hypothesis, the method, and the analysis plan. Post it on OSF or as predicted. This prevents harking, hypothesizing after results are known. It is the strongest signal that the work is not p-hacked. Practice 2: Open data. Share raw data, process data, and the processing pipeline. The 2020 gene expression paper in Communications Biology shared data and analysis code alongside the paper. The 2015 paper on honeybee evolution in Molecular Biology and Evolution made its sequence data publicly accessible. Use Zenodo for archival with a DOI. Use GitHub for version-controlled code. Practice 3: Open access. Publish in open access venues or post preprints. The Active Inference Institute publishes ecosystem snapshots annually on Zenodo with DOIs. The 2023, 2024, and 2025 snapshots document the growth of the community, its software, and its publications. Open access means anyone can read, cite, and build on the work. Practice 4: Open peer review. Use Open Review or PCI for transparent peer review. Reviewers are named, reviews are published, and authors respond publicly. This makes the review process itself a subject of study. The Active Inference Institute in numbers. Over 192 works published from 2015 to 2026, spanning entomology, active inference, cognitive security, art and synergetics, and computational frameworks. Over 500 live-stream sessions. 10 textbook cohorts. 5 annual symposia. Open-source frameworks including Cerebrum, Goference, and the GNN notation system. An internship program running since 2022. Teaching at College of the Redwoods. All built outside a traditional academic department, as a 501c3 nonprofit. The work spans domains that might seem unrelated but are connected by the same principle: understanding how agents infer, act, and minimize surprise. Entomology studies ant colonies as distributed inference systems. Active inference formalizes that principle. Cognitive security applies it to information ecosystems. Art and synergetics explore it through geometry and Blake. Computational frameworks build tools for it. The unifying thread is the free energy principle. Checkpoint. Which open science practice has the highest impact on credibility for an independent? The full pipeline. Start with a hunch. Sharpen it into a finer question. Search the literature to build the prior. Get feedback as a Bayesian update. Build credibility through ORCID, preprints, and open code. Avoid the common mistakes. Find a community. Pre-register. Submit. Iterate. The research pipeline is a perception action loop. The researcher perceives the state of the field. Acts by producing new work. Observes the response. Updates the model. Acts again. The loop never closes, it tightens. The complete toolkit. Finer for question quality. Falsifiability as the acid test. Literature review as the Bayesian prior. Preprints for priority and feedback. Reproducibility as the credibility foundation. The PONDP framework for structuring the research process. Open science practices, pre-registration, open data, open access, open review. And the Active Inference Institute as a model for building an institutional home outside academia. What to do tomorrow morning? Write the research question in one sentence. Search AR14 for 5 relevant papers. Read them. Write the gap. Get an ORCID, it is free and takes 2 minutes. Pre-register the hypothesis on OSF. That is day 1. Independent research is a different path. It requires more discipline, more self-criticism, and more deliberate community building. But it offers a freedom that institutional research rarely does, the freedom to choose the question. The Active Inference Institute exists because someone chose to build it rather than wait for permission. The path is open. Choose well. And begin.